Good morning and welcome. My name is Jamie Monat, and I am a professor in WPI's Department of Corporate and Professional Education. And today I'd like to tell you a little bit about a new course that we've developed entitled System Optimization, which is SYS 579A. So, what is system optimization? We've developed this handy definition, and our definition is that system optimization is the design and operation of a group of independent but interrelated elements comprising a unified whole to make it as good as possible in some defined sense while meeting specified constraints of minima or maxima. Now this statement, in some defined sense, that's what the challenge is. What defined sense? Because an optimized system to me may not be the same as an optimized system to you because we're different people and have different values and different things are important to us. So that's one of the interesting things in the class. How do you decide whose optimized sense you're talking about? Because of that, the course includes both quantitative and qualitative elements. It really is a combination of both art and science. Let me tell you a little bit about my teaching philosophy before we get into the meat of this introduction. I like to teach in a very hands-on style. I don't like lecturing. I remember what it was like sitting in the classroom where you folks are now. I didn't like it. It was boring. I didn't like being there, being the recipient of lectures, and I don't like standing up in the front giving the lectures. It's tiring, and I don't think it's the best way to learn. So I try to emphasize projects, student projects, in-class experiments, and demonstrations, things like that. For example, in this course, System Optimization, one of the projects that we do is the design and optimization of a pond algae skimmer. Where you have a pond with algae on the top of it, and you want to design some skimmer device that's going to skim the surface of the pond, take that material through a pump, flow it to some kind of filter, and return the filtered water back to the pond. Now that's a very challenging optimization experiment. Another example of the kinds of projects we do in this class is sports team roster optimization. Amazingly enough, that's a system optimization problem. We'll talk about that as well. When you have a home entertainment system, speakers, a stereo system, a TV, maybe an Xbox or a Wii or something like that, you have your choice of the components. And of course, the objective is to optimize that by maximizing your entertainment value while minimizing the expense. That's a system optimization problem. And lastly, military vehicle design optimization. You know, military vehicles have a particular design mission, and it might be to save as many wounded soldiers as possible. It might be an attack mission. It might be long range, behind enemy lines, etc. And you have to design a military vehicle to minimize its cost while maximizing its ability to perform its design mission. All those are examples of system optimization problems that we talk about during this course. Very important, I want the things that are taught in this course to be relevant to the real world. And I want to give the students usable tools that they can take with them and use on the job wherever they happen to end up.